Received several emails from folks that were struggling with problems 23 through 26 in the homework. This video will address all of those questions. Remember, this is for, we're going to use Statcrunch to do hypothesis tests for a proportion. And I'm going to work through question 23 here, and this should give you what you need to finish. So before we go into actually working the question, let's go through the steps for hypothesis testing for a proportion. We're going to write the claim mathematically using the null and alternative hypothesis, same as we did before. We're going to use the null hypothesis to assume the population proportion and the alternative hypothesis to determine if left, right, or two-tailed test. We're going to identify the sample proportion p hat, the sample size n, the number of successes x if it's given, and we're going to talk about that in a second, and the significance level alpha. You will need the x value to use Statcrunch. If x is not given, multiply p hat times n to find x. Remember, we learned this in the previous chapters. Use the decimal for p hat, which must be between 0 for 1. Now, we're going to find the critical values based on the significance level alpha, and I think that's what's throwing everybody off. We discussed this in the previous video, both from the chapter 6 work and the chapter 7 work on critical values, but we're going to review that again here. Use the Statcrunch Normal Calculator to find the critical value or value z and locate the rejection regions on a graph. Focuses on the p-value method for this class. So even though these homework questions ask you to identify the critical value in the rejection region, you can still use the p-value to make your decision. State the rejection criteria, p less than alpha, if using the p-value method. Calculate the test statistic using Statcrunch. In this case, it'll be a z, always for proportions. We're going to determine the p-value using Statcrunch. We're going to decide to reject or fail to reject the null hypothesis, and we're going to interpret the decision in the context of the original claim. So you see, in many ways, it's very similar to what we've been doing, but we're going to use a different Statcrunch function for doing hypothesis tests with proportions. And if you'll recall, it's the same one we use for doing confidence intervals with proportions in the last chapter. So we're going to work problem number 23. In this problem, we're given a sample size and p hat. To use Statcrunch, we will need to find x using p hat times n. So here's the question. A medical researcher says that less than 76% of adults in a certain country think that healthy children should be required to be vaccinated. Well, this gives us our claim right here, which is p less than or equal to 0.76. In a random sample of 200 adults in the country, 74%, that's p hat, I'm sorry, this up here would be your population p for the claim. This is p hat, 74% right here, think that healthy children would be required to be vaccinated. At alpha equals 0.05, is there enough evidence to support the researcher's claim? Completes parts A through E below. So we have already identified the p as less than 0.76. It's a left-tailed test, which means that the claim will go down under the alternative hypothesis. And of course, the condition of equality must be in the null hypothesis greater than equal to 0.76. So this is constructing your null and alternative hypothesis is the same as what we've been doing. Except we're going to, I don't know if anybody noticed, but there's a mistake. Both of these should be p, not mu. You can tell I copied this from a previous document, so let's fix those. So what do we know? We know n is equal to 200. We know p hat is equal to 0.74 from the summary statistics. So if we take 0.74 times 200, we get 148. So x will be 148 and alpha equals 0.05. Now, before we go into running the test, let's recall this question requires us to identify the critical value or values and identify the rejection region. Recall the previous videos on finding critical values. To find this z critical value, we will use the normal calculator in Statcrunch. Since this is a left-tailed test, the inequality symbol is set to less than or equal to, and the probability is set to 0.05. This identifies a critical value of negative 1.64. The rejection regions, whether two-tailed, left-tailed, or right-tailed, will always be the regions in the tails of the distribution. For this problem, that probably should be distributions. For this problem, the rejection region is z less than negative 1.64. Any test statistic less than negative 1.64 would indicate that the null hypothesis must be rejected. This would be accompanied by, instead of will be, I want to say would be. If you had this situation come up, this would be accompanied by a low p-value. Again, this is about the unlikely events that would give us a cause to reject. Now, when I put this in the normal calculator, I use the standard function because I'm doing a left-tailed test, so I only need this shaded area in the left tail. The mean is still set at 0 and 1. My x, notice I changed this symbol to less than or equal to, and I put the 0.005, the significance level over here, and I get a rounded z-score of negative 1.645. This is kind of a common z-score for many hypothesis tests will be run at a significance level of 0.05. So there's my critical value. Now remember, I don't need the critical value to run the test. When we run the test, we're given a test statistic and a p-value. For this test, we get a test statistic of negative 0.66 and a p-value of p equals 0.2539. When compared to the given alpha of 0.05, we see 0.2539 is significantly greater than 0.05. If the null is high, it must fly. So we fail to reject the null hypothesis. Now let's look if we were using the test statistic method, because it will always agree. So if we're using the test statistic, when we compare the critical value, we get negative 0.66. Well, that's greater than negative 1.64. On the negative side, I know that gets a little bit tricky, but if we were to graph this, we would see this would actually fall on the number line to the right of this value here, which means it would not be in the tail, which means it would not be in the rejection region, which would verify that we are going to fail to reject. Now, I'm going to run this problem in Statcrunch. I'm going to pull it up in just a minute, but this is what it looks like. 148 for the number of successes, 200 for the number of observations, which is n. This is x, this is n. My hypothesis, null hypothesis of p equal to 0.76. My alternative hypothesis of p less than 0.76. Don't be worried that this is not less than or greater than, less than or equal to or greater than or equal to, because that's the way Statcrunch works. You just enter everything as equal, no matter which one of the tests that you run. And when I run the test over here, you'll notice there's my x, there's my n, there's my z-stat, the negative 0.66, and there's my p-value, 0.2539. So what does this look like? Let's pull up Statcrunch and see. Stat, proportion stats, one sample with a summary. And my 148 is my x, goes in this first field. Then I'm going to put 200 in the second field. I'm going to change my hypothesis to 0.76 and less than 0.76, making it a left-tailed test. And I click compute, and there we have it. I'm going to go ahead and pull up so that's how you would run that test. And like I said, the p-value is enough to make my decision of fail to reject. But notice when we use the test statistic method, you notice we came up with the same result. We're still going to fail to reject. So from there, let's go back to our document and let's look at the problem. We have everything to answer all the questions now. So the first part, let's see. Let P, the first part is less than 76% of adults in the country think that healthy children should be required to be vaccinated. So that was the claim. And when we do put that in for our claim, we get a p greater than or equal 0.76 and a p less than 0.76, this choice out here. We showed how to find the critical value of negative 1.64. That's the rounded value. And we used the normal calculator in Statcrunch to do that. And we come in, we identify the rejection region. So that would be any test statistic Z that is less than negative 1.64. Now, if we see my test statistic is negative 0.66, we see that we are going to fail to reject. And I have the p-value method that I've already looked at, so I know I'm going to fail to reject. So if we think about the claim here is in the alternative hypothesis. So if we fail to reject the null hypothesis, what we're saying is there's not enough evidence to support the researcher's claim. I hope you find this helpful. This should get you through all the questions for Chapter 7 and get you ready for that test. And we only have a little bit more after this on correlation and regression, and won't take very long. So we're coming near the end. I appreciate all your hard work, and I hope you found this helpful.